In a parallel service configuration where you have multiple panels fed from a single meter, such as a 100 amp panel and a 200 amp panel, it's essential to understand the correct grounding and bonding practices. The fundamental principle is that the neutral conductor and the equipment grounding conductor should only be bonded together at one single point. This point is typically at the service entrance, often within the main service disconnect or the first panel served by the utility. Bonding the neutral and ground at multiple locations creates parallel paths for neutral current, which can lead to several problems. Firstly, it can cause unwanted current flow on the equipment grounding conductors. These conductors are designed to carry fault current back to the source to facilitate the operation of overcurrent protective devices like circuit breakers or fuses during a fault condition. However, if neutral current is also flowing on these grounding conductors, it can create elevated voltage potentials and increase the risk of electrical shock. Secondly, multiple bonding points can interfere with the proper operation of ground fault circuit interrupters, also known as GFCIs. GFCIs work by detecting differences in current between the hot and neutral conductors. If neutral current is diverted onto the grounding system due to multiple bonding points, the GFCI may not function correctly, potentially failing to protect against ground faults. Thirdly, having parallel neutral paths can cause electromagnetic interference, also known as EMI. The unintended current flow on the grounding conductors can radiate electromagnetic fields that can disrupt sensitive electronic equipment. Now let's discuss the correct grounding procedure for a parallel service. The neutral conductor from the utility service should be bonded to the equipment grounding conductor at the service entrance. This is the only location where this bonding should occur. From the service entrance, separate neutral and equipment grounding conductors should be run to each subpanel, such as the 100 amp panel and the 200 amp panel. At each subpanel, the neutral conductor should be isolated from the panel enclosure, and the equipment grounding conductor should be bonded to the panel enclosure. This ensures that the equipment grounding system provides a low impedance path for fault current back to the source without carrying normal neutral current. The size of the equipment grounding conductor should be determined based on the size of the ungrounded conductors feeding the subpanel, in accordance with the National Electrical Code, also known as NEC Table 250.122. For example, if the ungrounded conductors feeding the 200 amp panel are number 3/0 copper, the equipment grounding conductor would need to be at least number 4 copper. Additionally, it is often necessary to install a grounding electrode system to supplement the equipment grounding system. This grounding electrode system typically consists of one or more ground rods, ground plates, or connections to a metal underground water pipe. The purpose of the grounding electrode system is to provide a connection to the earth, which helps to stabilize the voltage to ground and provide a path for fault current in case of a ground fault condition. The grounding electrode conductor, which connects the grounding electrode system to the equipment grounding system, should be sized in accordance with NEC Table 250.66. The grounding electrode conductor should be connected to the equipment grounding bus at the service entrance. Now let's talk about some common mistakes to avoid when grounding parallel service panels. One common mistake is bonding the neutral and ground at multiple locations, as we discussed earlier. Another common mistake is using the metal conduit as the sole equipment grounding conductor. While metal conduit can provide a path for fault current, it is not always sufficient, especially for long runs. It is always best to install a separate equipment grounding conductor in addition to the metal conduit. Another mistake is using undersized equipment grounding conductors. It is important to size the equipment grounding conductors in accordance with NEC Table 250.122 to ensure that they can safely carry fault current. Another mistake is neglecting to install a grounding electrode system. The grounding electrode system is an important part of the overall grounding system, and it should always be installed unless there is a specific reason not to. In summary, to properly ground parallel service panels, you should firstly bond the neutral and equipment grounding conductors only at the service entrance. Secondly, run separate neutral and equipment grounding conductors to each subpanel. Thirdly, isolate the neutral conductor from the panel enclosure in each subpanel. Fourthly, bond the equipment grounding conductor to the panel enclosure in each subpanel. Fifthly, size the equipment grounding conductors in accordance with NEC Table 250.122. Sixthly, install a grounding electrode system and connect it to the equipment grounding bus at the service entrance. By following these guidelines, you can ensure that your parallel service panels are properly grounded and bonded, providing a safe and reliable electrical system. Always consult the latest edition of the NEC and local electrical codes for specific requirements and guidance. When working with electrical systems, safety should always be the top priority. If you are not comfortable working with electricity, it is best to hire a qualified electrician.